Hi everyone. In this video, I'm going to continue working through a grade 8 past paper. Please let me know if there's any questions. Let me know in the comments. So if we carry on, we've got a patterns question or sequence questions to begin. So study the pattern in the figures below and then answer the questions that follow. Okay, so we can see this is the first figure. We've got one triangle. Second figure, we've got 4 triangles. Third figure, we've got 9 triangles. Okay, so the thing with sequences, you've always got to figure out how do we get from one term to the next, or what's the rule? So I always try check, first of all, you try see, can you add anything? Okay. Here we can see not really going to work because 1 add 3 is 4, and then 4 add 5 is 9. And so we don't really know. Maybe there's a pattern there, maybe not. The other thing I always check is, are they square numbers or are they cube numbers? Okay, so let's give that a try. So if I go the first pattern, so pattern number 1, so 1 squared, that'll give me 1. 2 squared, that'll give me 4. 3 squared, that'll give me 9. Okay, so we can see that's kind of the pattern. That's not what they're asking for in this question, but it does help us. So we can say 4 squared is 16, and then 5 squared is 25. Okay, so usually if you're struggling to come up with, okay, I can't add anything, I can't times anything, can't subtract anything, then check, because often they ask, is it a square or is it a cube number? So we've got those two filled in. Write down the general term for this number sequence. So we've just figured that out. Okay, so the general term is you take the pattern number or the figure number, so that's n, and then you just square it. If we have a look at question 5, we've got an algebra question. So they're asking us a few questions here. So first of all, they're going to say, or they say, write down the constant term. So the constant term is always just the number that doesn't have any variables. So it doesn't have any x's or any y's. So we can see our constant term here is this 4. So nice, easy mark there. What is the degree of the expression? So this is, what is the biggest number? So the biggest exponent. Okay, so what is the biggest exponent? So we can see here, the biggest exponent, let's just get a different color, is we've got x squared. So that is our biggest exponent. So that means it is a second degree expression. Okay, so you just, if it was 3, then you would say a third degree expression. If it was 4, you say fourth degree. Because it's 2, that's our biggest exponent, so we say second. Write down the coefficient of the second term. Okay, so our second term is, this is our first term, so this is our second term. And they want the coefficient. So the coefficient is always the number in front of the x. So the coefficient here is just 5. So they just want to know what is the number attached to the x. And then 5.1.4, nice calculation question. So calculate the value of this expression if x is minus 1. So all that means is wherever you see x in this expression, you're going to put minus 1. So what we're going to do is write it out. So 7, okay, remember x squared. So wherever we have x, we're going to put minus 1. So minus 1 squared. Then we've got 5 times x, so 5 times minus 1. And then we've got 4. So we just, wherever there was x, we put a minus 1 instead. I'm just putting the brackets because it makes it a lot easier to see what's going on. Then we're just going to work it out. So let's work out the square first. So we're going to leave everything. So 7 minus 1 squared. That means minus 1 times minus 1, which is going to give us positive 1. Okay. And then let's sort out the signs here. So 5 times minus 1 is going to be minus 5. Add 4. And then if we simplify it again, we're going to go 7 times 1 is 7 minus 5, add 4. And if we just work this out then, so 7 take away 5 is 2, add 4 is 6. And so that is the value of this expression when x is minus 1. Then next up, we've got a simplifying question. So simplifying means add up all the x's, add up all the y's, add up all the numbers. So try get it. So you've just got one x term, one y term, and one number term. So if we have a look at this one, we're going to check out the x's first. So let's get a highlighter. So we've got 2x and we've got minus 3x. It's really important you keep that sign in front of them. Okay, so let's sort out our x's first. So in our x's, we've got 2x minus 3x. Okay, so we're just going to work this part out. So 2x minus 3x, just write them next to each other. Then let's have a look at our y's. So our y's, we've got minus 3y. Remember that sign in front is really important. And minus y. So we're going to write those next to each other. Minus 3y and minus y. And then finally, we're going to look at our constants. So our constants, we've got, sorry, let's get a different color highlighter. Our constants, we have positive 4 and negative 2. Okay, so we're going to write those next to each other. So positive 4, negative 2. It doesn't matter if you change it around like this so the similar terms are next to each other. Just make sure you, like I said, you keep the signs. So let's simplify then. 2x minus 3x, that's going to be minus 1x or just minus x. You don't have to write that one. Minus 3y minus another y is going to be minus 4y. And 4 minus 2 is going to be 2. And so that is as far as we can simplify that because we can't add any of the x's and y's together. So that is the answer that we get for that one. Okay, 5.3, we want to calculate these terms. So what we're going to do is we're just going to see how far we can simplify these. We should be getting, if we do this right, we should be getting it down to just maybe just a number. So let's give it a go. So if we've got that first term, we can't do much with this 4x plus 3 yet. So let's just write that again. Let's get rid of this bracket first. So when we've got a minus like this in front of the bracket, it means we're actually timesing everything in the bracket by minus 1. So we're going to go minus 1 times 3x is minus 3x. And then this is the part people often forget. Okay, so we do it to the first term, we have to do it to the second term as well. Minus 1 times minus 2 is going to be positive 2 because a minus and a minus makes a positive. Okay, then we're going to sort out, we're going to try to simplify like we did in the previous expression. So we're going to go, let's work with our x's first. 4x minus 3x. Okay, so 4x, take away 3x is just going to leave us with 1x or just x. You don't have to write the 1. And then 3, add 2. So 3 plus 2 is going to be 5. Okay, so in the end, our final answer is going to be just x add 5. Can't do much more than that. That is as far as we're going to get. With the next one, we've got a fraction. What I always try to do with the fraction first is let's try simplify the top separately and the bottom separately. So what we can do at the top is we can actually take out a common factor of 6 here, okay, because 6 goes into each of those terms. So at the top, we are going to take out a common factor of 6. So what we have left is 18 divided by 6 is 3x squared. 12 divided by 6 is 2x. And 6 divided by 6 is 1. Okay, which looks, it doesn't look that much simpler yet, but you're going to see why we do that in a sec. Then we have this 6 at the bottom. Then what we can do is we can actually go 6 divided by 6, we can cancel those. Okay, so we are left with 3x squared minus 2x minus 1. And then we could potentially factorize this. So let's see. I think that's probably as far as we're going to go for now. So let's leave it at that for now. 5.4, complete the simplification steps below. Okay, so let's see. What they want us to do is when we times things like this, we can make this into one term. So we can group it all together. So 2 times 3 is 6. Y times y squared is y3. And then the same thing here. So 14y times y squared, we're going to have 14y3. And we can see they're kind of helping us along here. So then we can say 6y3 minus 14y3, they've got the same exponents, so we can actually subtract them. So 6 take away 14. So 14 take away 6. We can do it either way. You can do it the other way around. So you could say 6 take away 14. I like to just go bigger number first to get the same answer. Just make sure you get the right sign. So 14 take away 6 is going to give you 8. Okay, so that's going to be negative 8y3. Okay, then we are moving on to some solving questions. So we're going to be solving for x. We start off with a pretty simple one. So we've got x minus 10 is equal to 2. What we always do is we want to get x on one side by itself and we want to get all the numbers on the other side. Okay, so that's the format that we're trying to go for. So in this one, pretty straightforward. All we need to do is get rid of this 10 so we can take that across. Okay, we were minusing 10. If we take it across, that means we're going to add 10 on the other side. Okay, so we're going to end up with x is equal to 2 plus 10. So you always take it across and do the opposite. So then x is going to be equal to 12. Next up, a little bit more, just a few more steps. You can see that's why we've got a few more marks in this one. But same process. So we were trying to get in this form where it's x by itself and then the numbers by itself. So to do that, we just do the opposite to try and get everything away from the x. So first of all, we are going to get rid of this plus 1. Okay, so remember we said if we take it across, we do the opposite. So we were adding 1. Now we're going to take away 1. So we're going to go 2x is equal to 203. Sorry, 203. Take away 1 because we want the opposite. So we're going to end up with 2x is equal to 202. This is fine. It's looking closer to what we want, but we always want the x by itself. So if we've got a number in front like this, what we're actually saying there is that it's 2 times x. We're going to take that 2 across. We were timesing by x. The opposite of timesing is dividing. Okay, so what we're going to end up with is x is equal to 202 divided by 2. So x is 101 then. Okay, just be careful in a question like this. If there's a number, like we had this 1 here, so if there's that number and then there's something in front of the x, make sure you get rid of the number first and then you do the division. Okay, and then the final one we've got is a cube one. Okay, and if we've got a cube like this, if I want to get rid of a cube, I need to cube root. If I wanted to get rid of a square, I need to square root. And so I'm going to say the cube root of this side, if I cube root one side, I have to do the same on the other side. Okay, so this case, the cube root and the cube cancel. So you're just going to end up with x. And then if you want the cube root of 64, that is going to be 4. Just have to check that, okay, because it's 4 times 4 is 16 times 4 would give me 64. Okay, so the cube root is just 4. Again, you've got your calculator, so you could just check that if you weren't sure. But 64 is one of those ones that we kind of know. You kind of start getting the hang of these cube roots and square roots. Okay, 6.2, fill in the missing value. So we've got a spider diagram or a flow diagram here. How this works is you have an x value, you plug the x value into an equation, and you get out a y value. Okay, so here they tell us when x is minus 3, they want us to work this equation out and get our y value. Okay, so at the top, we're just going to write. So when x is minus 3, so whenever we've got x, we're going to put in a minus 3. Okay, this works out then. So we got minus 2 times minus 3. So a minus times a minus gives you a positive. 2 times 3 is 6. Add 3. And so we're going to end up with our y value then is 6 add 3 is 9. And then kind of the same thing, but they want us to work backwards and find out what y would and what x would be. So they tell us y is 5. Okay. So in this equation, let's just write it out so we've got it. We can see what we're doing. They tell us y is 5. We need to solve for x. Okay, so it's very much like the questions before where we're solving for x. We need to try to get x by itself. So we take 3 across. We were adding 3, so now we're going to subtract 3. So 5 take away 3 is equal to negative 2x. This side, 5 take away 3 is just 2. So we got 2 is equal to negative 2x. Again, we're nearly there. We're getting closer, but we want the x all by itself. So we need to take this negative 2 across. So that is negative 2 times x. When we take it across, we're going to divide. So we're going to say 2 divided by negative 2 is equal to x. So 2 divided by 2 is 1. 2 divided by negative 2 means it's minus 1. So x is minus 1. So we can fill that in on our spider diagram then. So when x is minus 1, then y is 5. You could then plug that in and work it back if you wanted. So you could plug in you could say y is equal to -2 times -1 plus 3, and you can work out and check that you do get that 5. Okay, we'll do a few more. So question 7, choose the correct angle side from the list below only once to complete each statement. Okay, so this is geometry. It's stuff that you're going to have to know, okay, because otherwise you're really going to struggle. But let's go through, if you are struggling, we're going to work through the easiest ones first. So the sum of the interior angles of a triangle. So if it helps you, you can draw a triangle, and I always just remember it like this. So triangle adds up to 180. Okay, so interior angles of a triangle is 180. Then maybe you don't remember this one, or maybe you do, but equilateral triangle, all the angles in a triangle are equal in an equilateral triangle. So for that to happen, they each have to be 60, 60, 60. Okay, because then it adds up to 180. The largest angle in a right angle triangle. Okay, so if we look at a right angle triangle, a right angle triangle has that 90-degree angle in there, and then it's got two other angles. We can see that these two angles in here are smaller than the right angle. Okay, so that means the largest angle is the 90-degree angle, which is kind of in the name there, right angle. The sum of the interior angles of any quadrilateral. So let's say you didn't know this, we have already used these three. So we know then it has to be this 360. If you're not sure, try remember quadrilateral, think of a square, and it is 360 degrees. Quite a nice trick is if you have two triangles. So a triangle, we know a triangle is 180, and a lot of people remember that quite easily. If you have two triangles stacked on top of each other, 180, 180 makes a square, which is 360. Okay, so that's quite a nice trick that they don't always tell you. So two triangles makes a quadrilateral. So if you can remember, triangle is 180 degrees, two triangles is 360. Okay, 7.2. In triangle ABC, angle B is 70 degrees, so they tell us this, and angle C is 30 degrees. Calculate the size of angle A. Okay, the important thing, once we get into this geometry, we have to be giving reasons. Okay, so kind of nice. They did tell us actually up here, if you got this right. Okay, so we said the sum of the interior angles of a triangle. So angles of a triangle add up to 180. So we are going to use that as our reason now. So we know angles of a triangle should add up to 180. So I'm just going to block this off. Here's our reason. And here is our workings. Okay, so we are going to say angle A. Okay, that's how we write angle A plus 70 degrees plus 30 degrees should add up to 180. And the reason is because if I write it in shorthand, the interior angles of a triangle add up to 180 degrees. So you can use the shorthand, they should understand that. Then we're just going to work out what A is. So something plus 100 gives me 180. Okay, if we add those two up, so something 70 plus 30 is 100. Gives me 180. And then we're going to say, okay, well, that has to be 80 then. So A has to be 80 degrees because 80 plus 100 will give me 180. There we go. So we've got our 3 marks there for working and our 1 mark for our reason. Okay, 7.3, I think this will be the last question for this video, is again, we've got in this diagram, A is 40 degrees, so they just showed us that. B is 80 degrees, and now they want us to calculate the size of angle ACD. So it's always this middle one. That's what they're talking about. So ACD means they want this angle here. Okay, so you go from A to C to D. So they want that angle. Okay, we've got a few more steps here. So what you're going to say is angle ACD is equal to 40 plus 80. So again, this is something you have to know the rules. And the reason is the exterior angle of a triangle. So the exterior angle of a triangle is equal to the opposite interior angles. okay, which is a lot of big words for basically to say, if I get, let's get a different pen. It always works out like this. So if we have this exterior angle of a triangle there, so C, that is always equal to these two added up. Okay, and so we can quite easily work this out then, and we can just say ACD is 40 plus 80, so that is 4 plus 8, which is 12, so 120. There we go. This would be, you could work this out in different ways, but so you could work it out with angles on a straight line and interior angles if you wanted, but this is just a really short reason, and we can kind of see this is what they wanted here. I really hope this video helped. I'm going to keep working through this paper, but let me know if you have any questions in the meantime.